Good morning, everyone. Today our topic is related to the optical fiber. I think all of you should have been heard of what optical fiber is. But anyway, let me give you some basic information first. From some sense, optical fiber is quite a simple stuff. It is just a thin and flexible, transparent fiber similar to a plastic fiber. It serves as a waveguard. That is, it provides a route for light to pass through. Light can transmit from one end to the other. Optical fiber is categorized into the field of science and engineering. And the application design of optical fiber is named as fiber optics. Don't ever think that people make a mistake when you come across of optic fibers. Okay? Do you think that optical fiber is a new technology, or at least it should be innovated after the birth of the cow, Go-Kwan? In fact, it is quite a simple and old technology, originated in 1840s. Two scientists in Paris, that is Daniel and Jacques, guide a light beam by refraction. As you can see, the first optical fiber is made of water, just like that, okay? And this is the first demonstration and established the principle of the fiber optics back to 1840s, okay? Some years later, another scientist, John, did also open a demonstration in London. On the other hand, it includes the idea of the total internal reflection is in his introductory book about the nature of light. This is the quotation from his book. Okay. And in 1963, the use of optical fiber for communication was proposed by a Japanese professor, Junichi. And all we mentioned about can be known as the origin of the optical fiber. Okay. But up to now, you may wonder, where is Go-Kwan? Okay, and here you are. In the past, though someone has proposed the use of optical fiber, but it only lies on the theories because of the huge attenuation during the light transmission. And in 1960s, Charles Cow and his colleague George A. Hooken discovered that the attenuation could be reduced to below 20 decibel per kilometer. This turned theory into practical technology. Cow and George are so important because they found that the huge attenuation was due to the impurity of making materials. There were no fundamental physical effects such as scattering. They also theorized the light loss property for optical fiber. The most significant thing is that they suggest the use of silica glass to make fiber optics. This suggests helps to achieve the crucial attenuation limit of 20 decibel per kilometer in 1970. Thanks to all this, Cow won the Nobel Prize in Physics in 2009, and Cow is the father of optic communication and the owner of Hong Kong. Okay, and this is the history part.
After knowing the history of optical fiber, I will talk about the principle of its operation. Optical fiber is a cylindrical dielectric waveguide. It transmits light by the process of total internal reflection. In an optical fiber cable, it encrypts a pair of optical fiber, and this is the optical fiber. And the optical fiber is surrounded by the filling gel and some aluminum tape. Also, group the optical fiber together. The optical fiber is protected by the water blocking layer and some PE layer. My group has mentioned that the optical fiber is made from silica due to the high purity. And what silica is? Silica is the molecule that contain the silicon and the oxygen. It's the molecule of the silicon and oxygen. And some of the optical fibers may also made from other chemicals that usually produce gases and some crystalline materials. We have mentioned the total internal refraction several times, but do you know what it is? It's a physical phenomenon of light. It may occur only when light passes from one optical dense medium to less optically dense medium. The second condition is the angle of incidence has to be larger than the critical angle. This is the equation to calculate the critical angle, where the N2 is the refractive index of less optically less dense medium, and N1 is the refractive index of the less dense one. So here you can see the how light can pass through the optical fiber, and this one is the incidence angle, and this if it is larger than the critical angle, the light ray can be refracted. So I will just introduce how light can be transmitted, and then turn out will be the electrical output that we want. Firstly, we will just generate the light sources by some driving circuits, and then with the electrical input from the computer system, and then pass through the modulator electronics, and then these two sources can combine by the optical modulator and generate different light intensity of light that represent our digital signal. And then this optical output will be passed through the communication channel, and then after that we will just reach the photo detector, and then we can just separate the light ray and demodulate the electrical sources, and then finally we can just get back our 1010 at the end. And in the fiber optic communication channel, there are two ways to transmit the light. First, maybe the first one is we just use the transmitter to transmit light, and then after a certain distance, we will just degenerate. We receive the light signal first, and then we generate the light sources, and then again, and then finally reach the user of the materials, and then the receiver will just degenerate the light signal back to the electrical output. And the second way is just use the amplifier to amplify the light sources to maintain the light intensity, and then finally reach the receiver at a very long distance. And in the modulation, this part is very interesting if you have paid attention to our class. In optical carrier, this equation is similar to that we learned from in our class, but the difference is this one is in cosine function. But what we learned is in sine function. And then if we use the ASK, maybe we can use the amplified modulation that we learned just similar to AM. And then this is the amplitude shift key. And then we just modify the optical signal for amplitude 1 or 0. And then the FSK is the frequency shift key. And then the signal is shifted by shift the frequency by a fixed value or log shifted to represent the 1 0. And then the PSK is we modulate this one in the equation to so that the waveforms of light are fitted between 0 and 1. For the light ray, usually we will use the ASK in transmitting the light signal. For the optical picture, this is how the signal is transformed. There is two forms. One is return to zero signal, and one is non-return to zero signal. The return to zero signal represents if there is a peak like here, and then return to zero is represent the 1. But the non-return to zero is keeping the signal with a higher peak, and then just return to zero when the digital signal is 0. So here is how the optical fiber works in particle.
optical